Okay, we're going to review the Chapter 4 homework, and this will be a three-part video. In the first part, we're going to look at the first problem, 4.15, and that is after we have initialized the stack pointer and execute these instructions, these 6 instructions, what will be the contents of register A and register X? And he gives a hint to look at stack pictures, and I give another hint to try it in Texas if you're not sure. So from a stack picture standpoint, we begin by assuming that the stack pointer is initialized. That is, it's pointing somewhere. It might be at the very bottom or it might be somewhere else, but any values below it we didn't put on there, and so we can't make any assumptions about them. But once we load the accumulator A with 3, 4 and the accumulator X with 5, 6, 7, 8 and push them onto the stack pointer is decremented by 2. Since the push X is a 16-bit operation, it moves the 16 bits of the X register by populating the 2 8-bit bytes onto the stack. So 5, 6 goes first and 7, 8 goes second in terms of increasing memory locations. So that's the first operation. And then when we push A, that's an 8-bit push onto the stack. So the stack pointer is decremented by 1, and the value 3, 4 is put into RAM at that location, onto the stack at that location. So then when we pull X from the stack, that's a 16-bit pull. So the stack pointer is pointing here, so it'll pull 3, 4, 5, 6 and put that into the X register. And when we do an 8-bit pull, it'll get the 7, 8 and put that into the A register. So that's the correct answer. It seems a little odd, and this seems like maybe not the sort of thing you would normally expect to do, that we're rearranging bytes within a register. Looks like it might have been an accident, but that's what the result would be. But if we're not sure, let's try it in Texas. So what will we need to do in order to try this in Texas? Well, we've got those 6 operations, and we just need an org statement and a main and then a reset vector to try this out in Texas. So let's do that. Let's copy this code segment and go into Texas and paste it in there, and let's see if this is going to work for us. So there's no syntax errors, no missing values or anything, or so it would appear. So that looks good. Now we can assemble it. Let's go assemble. Let's turn off some of the options that count the number of cycles, because that sort of clutters up our listing file. So we'll assemble it, and we'll see this assembly was successful. So now we can minimize the log window, and we'll look at the list window. That's what we'll be using to watch the progress of the program. And we probably don't need the source file now anymore. We'll minimize that. And let's take a look at the registers. And here we want to look at the A register. We're not so concerned with the X register or the condition code or the program counter or the Y register, but we should watch the stack pointer and the A and the X register. And then we can also open a stack window with File, New, Stack. And we know we've got 3 values going on there, so we can set up the stack from 3FFA to 4000. We can monitor it. And putting those values in here with a capital H allows us to look at those. Let's look at them with a small h. That'll be in, yeah, that's probably right. We're only writing 3 bytes. It could be from 3FFD, 3FFE, 3FFF. And we'll monitor those in 8-bit fashion. So when we hit the reset button on the microprocessor, it pulls the address of main from the reset vector and loads it in the program counter and begins executing at 4000. When we execute the first instruction, we load the stack pointer to 4000. That works correctly. And then when we load accumulator A with 3, 4, then A is in accumulator A has 3, 4, and load X with 5, 6, 7, 8, and now 3, 4, 5, 6, 7, 8. Nothing on the stack yet because we hadn't put it there. So this next operation pushes X. That's a 16-bit push onto the stack. So there we see the 5, 6, 7, 8 going onto the stack. 5, 6, 7, 8. And when we push A, the stack pointer is decremented by 1. So now it's pointing to the 3FFD. And the 3, 4, 5, 6, 7, 8 is on the stack. So when we pull it X, when we do a pull X, we're pulling the top two values, the 3, 4, 5, 6, and putting that into the X register. And when we execute one more, the pull A, we're pointing to that 7, 8 and pulling that and putting that into the A register. So that's what we're left with, is 7, 8 in the A register and 3, 4, 5, 6 in the X register. And is that what we predicted here? 3, 4, 5, 6, and 7, 8. So that's how you work this problem and how you solve it easily in Texas, which is the way I would always recommend that you do on these problems to make sure that you have the right answer.